let's now understand about reactivity, preference of solvents, and how does actually the mechanism occur. Alright, let's understand a bit about it as we understood about SN1. Okay. Now in case of reaction, the reactivity is 1 degree, 2 degree, 3 degree. Why? Obviously. Now fastest would be for 1 degree carbon. Why 1 degree? Because less of steric hindrance. Now just example, check it out over here. Now here you have got absolutely increased crowding or steric hindrance. Alright, so just I am showing it in terms of small spheres, right? This, so it's sterically hindered. Whereas when you see primary, it's absolutely open. Alright, so it can happen. So least hindrance, so SN2 mechanism preferred. Why? No steric hindrance. Alright, whereas here there is steric hindrance. So whenever you are talking about primary chloride or primary, it would prefer SN2 mechanism. Alright, okay. And we have seen in case of tertiary, since it was stabilizing cation of tertiary, so that was preferred. In here SN1 preferred, here SN2 preferred. Fine. Okay, now preferred solvents. There we saw in case of SN1, we saw that we used a polar solvent because that was what was facilitating the reaction. Whereas here in this case we use low polarity. Alright, example benzene, toluene, hexane, etc. Why not polar solvents? Because if I use polar solvents, that would deactivate nucleophiles by stabilizing. So the polar solvent would deactivate this, as a result of which it won't be able to do the nucleophilic attack. It won't be able to do nucleophilic attack on the carbon. Right. Okay. So that's about solvent. Then again I've just tried to explain an example how. Now see, in case of secondary, alright, see, ethane, propane, butane. So it is butane, chlorobutane again, but 2-chlorobutane because Cl is attached to second carbon, right? IPAC. Alright, now that is what is compared with 1-chlorobutane. Alright, ethane, propane, butane. So 1-chlorobutane. Here in this case SN2 is preferred because there is no crowding, whereas here SN1 would be preferred, not SN2 because of crowding. Alright, so here it's SN1. As this Cl goes, this C2H5, this CH3 would stabilize C+. C2H5, CH3 are electron donating group. So when Cl leaves, it would be C+, stable, and SN1 preferred, whereas SN2 not preferred because of steric hindrance. Alright, so electronic factor and steric factor decides whether the reaction would be SN1 or SN2 mechanism. Alright, okay, study well.